Hello, we are Débora Egea, Samira and Enrique Moreno, and we are going to present the work about experimental bipolar and freehand knapping on quartz, alternative or different goals. Since the beginning of archaeological research at El Alto Ancasti Mountains, located in eastern Catamarca, Argentina, highlighted around lithic technology that the raw material selected almost exclusively was quartz, reaching 96% of analyzed lithic sets. This characterization was observed in 4 archaeological sites with different types of occupation, environmental characteristics, but with similar chronologies. El Taco 19 and Oyola 50 are domestic compounds. They have an important architecture with a clear work effort and are associated with agricultural terraces in both cases. Oyola 7 is a rock shelter with rock art. Its interior is about 14 meters long, 4 meters wide and 1.6 meters high. 77 motifs were documented on walls and ceilings of the rock shelter. Finally, Oyola 31 is formed by stone alignments which take the form of very open arcs. This row of stones contribute to support wooden posts that generated enclosures of perishable material. These could have been temporary or short-term living areas. These sites are contemporary according to the radiocarbon dates obtained on the second half of the first millennium of the era. Lithic technology recovered from this context allow us to interpret the use of local variety of quartz from quarries located nearby archaeological sites. On the other hand, there was a high fragmentation rate, a large amount of debris, and the manufacture of very simple instruments but with variable functionalities, such as scrapers, cutting instruments, notches, or drills. Also, the possible use of freehand and bipolar percussion were registered. Some of these characteristics are recurrent in many experimental research on quartz behavior. However, many of these backgrounds have focused on Paleolithic context of hunter-gatherer population with high mobility patterns. On the contrary, in our study case, settings are very different and the experimental study will allow us to approach the technological choices of anti-knappers considering that this population had agropastoral economy with low long-range mobilities. These technological choices are related to some key points. The first one has to do with the high fragmentation and debris rates to better understand the origin of this material in the studied context. But the main point is centered on knapping technique choices used for core reduction. As we said, bipolar and freehand techniques are interesting alternatives for reducing quartz cores to obtain blanks. But in addition, we explore the possibility of using anvil technique for the initial reduction of large pebbles. Knapping techniques are an important part of lithic production sequence. In relation to the manufacture of quartz instruments, it has been suggested that the use of freehand and bipolar technique. The difference between these techniques is that the first one holds the core with one hand and the other the hammerstone that performs the impact, while bipolar technique involves the use of an anvil where the core is supported and struck from above, generating an impact and a counter-impact. It has been proposed that freehand percussion generates greater thickness in quartz flakes and blanks, since percussion point is placed towards the interior of the percussion platforms to avoid internal fracture planes. This implies the need of bevel thinning to obtain edges of less than 40 degrees, suggesting a technical skill to obtain this type of edge that wasn't registered in the lithic assemblages study. The risk of trying to obtain a thinner flake is blank fracture. From this premise, the idea arose that by bipolar knapping, thickness of blanks and flakes could be smaller. The third technique that we believe could be used is anvil knapping. This could reduce core size and generate suitable percussion platforms. The difference between this technique and bipolar is the minimal importance of counter impact in the support sector. So, to test these two proposals, A, the bipolar knapping used to decrease blank thickness for the manufacture of specific instrument, and B, the use of anvil percussion for the initial reduction of large pebble, we carry out experimental study. For the experimental analysis, we used 22 quartz pebbles in 27 experiments, since in some cases tests were carried out alternating between knapping techniques. Pebbles were collected at the two locations where our research was focused and have different shapes and sizes. Stone hammers of quartz were used and also of schist and granite. Of the 27 experiments, 11 were performed by freehand percussion, 12 by bipolar knapping, and 4 by anvil percussion. 4 pebbles were tested by alternating the 3 knapping techniques. There was a pebble that was initially worked by freehand percussion, and when its size was considerably reduced, we continue with bipolar knapping. For freehand percussion, mainly quartz stone hammers were used, which presented better characteristics on blank preparation. On the other hand, both for bipolar and anvil, the best results were achieved with heavier and bulkier schist stone hammers. Only those materials over 20 mm were analyzed. Through the experimental study, a total of 1,039 flakes were obtained, of which 613 were from freehand, 290 by bipolar, and 136 by anvil percussion. This indicates at first glance a greater amount of material obtained by freehand knapping, but this is directly related to the size of cores and experiment participant elections. The experimental results showed that the fragmentation rate was around 60 and 70%, very similar against archaeological site material. By freehand percussion, fragmentation rate is lower. Other result is related with the large amount of debris recorded in the archaeological site, which reached values of 30%. Through freehand and anvil percussion, the percentage of debris was 22 and 29% respectively. This would indicate that the values observed at archaeological site would not be overrepresented. But here there is an important difference between knapping techniques. Bipolar indicated only 7.7% of debris, so it could be more blanks in relation to the amount of material extracted from core. Returning to the original proposal about this experiment, we suggest that the objective of bipolar knapping could be explained in the specific search for blanks thinner and with laminar shape. This is indicated by the presence in the archaeological sets of cutting instruments with thin or very thin thickness, and that we think would be very difficult to obtain by freehand percussion. In relation to laminarity of bipolar flakes, it has not been observed. We notice very similar percentage in the large width modules. In thickness case, there is a clear trend towards a lower thickness of flakes obtained by bipolar knapping. This, we think, would be the main objective of bipolar use in the past, since the access or conservation of raw material or the mobility of this instrument would not have been important aspect for the population that occupy eastern Catamarca. But now, one characteristic of quartz knapping that we intend to understand is linked to how we can identify bipolar quartz flakes. In our case, we couldn't identify clear technological features that would allow differentiation. The presence of encountered ripple marks in the case of quartz is not generally observable. Perhaps the most clear aspects are crushed platform and terminations, since they occur in practically all flakes obtained by bipolar knapping. And the same doesn't happen in the case of freehand percussion. However, the high rate of fragmentation as well as pebble retouching make this stigma disappear or be underrepresented. An aspect that appears to us as relevant in the case of study is the presence of filiform and pointed striking platform as a particular feature of this technique. If we evaluate the presence of striking platforms, we can observe that there is a greater representation of these types in the results by bipolar knapping. This could be a relevant contribution to identify bipolar knapping in archaeological sites, as was suggested by Parketer and De La Peña in 2017. The last point on which we want to stop is about the use of the different knapping techniques probably used during the past. In our case, it could be an articulation linked to the preparation of specific blanks for the manufacture of particular instruments. In addition, we evaluate the use of anvil percussion as an alternative. This technique could have been linked to the early stages of core reduction. This is explained by its large size and hardness, difficult to reduce by freehand percussion, and probably obtain larger flakes. By anvil percussion, we were able to better reduce pebbles and general percussion platform. Finally, it is clear that bipolar knapping requires cores smaller than 15 cm, since it is practically impossible on bigger sizes that the force of the impact rebound on anvil and be able to obtain blanks. Therefore, we believe that at some point, ancient people decide to change from freehand to bipolar percussion to continue the reduction stages, but not as a maximizing response of quartz utilization, but with the aim to obtain certain specific characteristics on flakes. We believe that the experimental research carried out provides relevant information about people and quartz relationship at eastern Catamarca during the first millennium of the era. In this sense, it contributes specifically around the technological choices of this population, with low mobility and simple and close access to raw material, so the decisions are very different from those analyzed in relevant backgrounds at global scale. Knapping techniques and artifact manufacture were introduced into a social dynamics in which they were articulated with other activities such as the construction and remodeling of houses, the work on agricultural spaces, animal herding, and domestic reproduction. There we believe that the use of this technique could have involved possible alternatives to reduce cores, aimed at obtaining better results, particularly related to blanks and reducing quartz limitation, especially in relation to fracture planes, hardness, and inclusions. In addition, this knowledge and established relationship are framed in a locally situated way of life, in which the links between people and between them and the landscape were the central source of social reproduction during the first millennium of the era at El Alto Ancasti mountain.